This mid-power rocket is completely 3D printed, but there's something special about it. It's these LEDs. That's because it's meant to fly at night. Now normally, other than looking cool, flying a rocket at night, at least in the hobby world, has no practical purpose. But with Project Vulcan aiming to capture high-altitude footage of the Perseid meteorites as they enter the atmosphere, we can't launch during the day. We have to launch at night. And if you want to know more about why, then watch this video. Now, if you've ever seen a night launch, you might notice that the rockets have some form of illumination on them. Why is that? According to the rules published by NAR, or the National Association of Rocketry, a rocket that flies at night must be actively lit through the entire flight, must be visible from at least 300 feet away, must be lit after landing, and have a proven track record of at least one daytime flight on a similar motor impulse. As well, there is typically a lower launch waiver that the paper states as being somewhere around 2,500 feet AGL, or above ground level. A quick Google search reveals that the launch waiver at night for my club is 3,000 feet AGL, but there are also a few new rules that get added on top of the normal rules. First, the rocket must weigh less than 15 pounds when loaded. Second, the vehicle must have a second independent illumination source if it is not a commercially available kit. First of all, we're going to need a light source for the rocket, and that will come in the form of these white LEDs. We will have 2 on the side of the rocket, and then 2 in the avionics bay. But before we put any LEDs on this vehicle, we need a way to power them. That is going to happen with this 9-volt battery. But there's a problem. If I plug a 9-volt into a LED, it completely fries the bulb. If we want to run 4 LED bulbs, then we are going to need an LED driver. So let's make one. After drawing up a diagram for the LED driver, I decided to build a small LED driver as a prototype, and I learned a few things along the way. First of all, I found that I need new wires. These little connectors that I have right now are not going to cut it, so I'm going to get some of that proper wiring in the future. Second, I learned that resistors get a lot hotter than I thought they would, so I was concerned that I might have used too low of a watt resistor. So I decided to let this LED driver run for a while to make sure the resistor wouldn't burn out. Unfortunately, the GoPro ran out of space on the SD card, but the LED driver ran for an hour before I turned it off. Now that we have that done, we can start constructing the first of 2 LED drivers. We need 2 because, as you'll recall, the rules for flying at night at the TCR range is that if the rocket isn't a kit, then you need a redundant light source. What that means is we need different LED drivers with 2 different power sources. Neither of these drivers can have a single point of failure. In the aerospace industry, this is known as full dual redundancy. No single point failures. Now, with all that covered, let's build this board. Oh, guys, I thought it was gonna be so easy. Here's the problem. This board shorted. So I made a few more, and when I did, I changed the design because I realized that we don't need a resistor for each LED. So I made a few more drivers using only one resistor to drive a single LED. So before we continue this, let's talk about where we are going to put the LEDs. Because we have this separation joint for the parachute to come out, we have a brake wire which will sever the electrical connection to the LEDs on the booster section of the vehicle. So we will have a set of LEDs in the avionics bay to create a light on the parachute canopy so we can keep eyes on it the whole way down. Then we will have two LEDs in two holes on the side of the rocket. But here's the problem. These LEDs will not function unless we have an LED driver, which we currently do not have. So let's get back to making those LED drivers. I built multiple LED drivers and all of them shorted in some way. So I started building another driver, and with this one, I wrapped all of the bearer solder joints in shrink wrap. I mean electrical tape. But wait, before you get up in arms, I will be getting shrink wrap soon. Now, before we solder this board to the LEDs and the brake wires and put it into the av bay, we need to test this. So I plugged it into a 9-volt battery and left it on with a stopwatch next to it and watched from a safe distance in case the resistor blew out. Unfortunately, the GoPro ran out of SD card room again after about 12 minutes, but the LED drive and the LED ran for about 15 minutes before it turned off. Now that we have tested the av bay light, we can now build the backup and the LED driver for the two LEDs in the booster. After I finished constructing all the LED drivers, I tested them to make sure there were no defects or shorts. The reason I'm doing this is because I don't want to glue these into the av bay and then find out that they don't work. Oh, you guys thought I was going to build an avionics sled? Well, we'll come back to that soon. Before I conducted the tests on the flight articles, I lathered an old board in hot glue to make sure I wouldn't fry the drivers with the glue like my dude Joe did over on his channel, BPS Space. Now that I know that I won't fry the drivers when they are mounted in the vehicle, we can run those performance tests. testing, I inserted the 2 LED drivers for the 2 LEDs that stick out of the vehicle. After this, I inserted the LEDs into the vehicle. But before that, I soldered an extension to the 2 LED anodes. After this, I inserted them into the vehicle and potted them in hot glue. By the way, yes, there will be a hot glue rocket. After this, I soldered the quick disconnects to the LED extensions, which, considering this is inside a vehicle that is made of PLA, you know, the plastic that melts at 190 degrees Fahrenheit, this was nerve-wracking. Luckily, I made it through it without damaging the vehicle. Now that we have everything situated, wait a second, let's just go back. What is that? Man, if you guys aren't aware, I actually don't use motor retention hardware. I use motor retention hardware. I don't use parachute retention hardware. I haven't used it before. So all my rockets have the shock cord glued in. Oh, that's a great idea. Ah! You idiot! You could have killed the flight! Anyway, let's fix this problem with hot glue. After this incident, I taped down the shock cord using electrical tape, and I dumped a metric ton of hot glue on the mounting point. And this did lead to an unholy looking forward section, but it did totally work. In the future, though, we're going to have dedicated mounting hardware for the recovery system. After this, I had put so much hot glue on the shock cord that the upper section couldn't fit all the way down on the coupler. So I printed a piece of airframe and used it as a switch band over the coupler. After that, I cut the hot glue joint from when I broke this rocket. That will be linked in the upper right-hand corner if you want to see that. Now it's time to get to work putting all this into the avionics bay. But if you haven't seen the video where I build this rocket, then you should pause this video right now and go watch that video, which will also be linked in the upper right-hand corner. But here's the thing, I accidentally printed the nose cone for this rocket solid, so there's a whole lot less space than I should have for this rocket. Then while placing it in the av bay, this happened. I broke one of the LED drivers, and this is when I decided that I should not push something like this, and I should take these drivers and put them in a larger vehicle. So after thinking it over a little bit longer, I decided that the next vehicle for Project Vulcan will be a 4-inch rocket that will be designed for flying at night and will not have a solid nose cone. Keep an eye out for that video. That will be coming soon on the channel. That's all that I have for this video, but before I leave you with my new outro, thanks to Everyday Astronaut for that music, I want to tell you about my Patreon page. I only post on average once a month, especially when this project is super long and I want to get it all into one video, such as the project that I definitely never accidentally destroyed. Video linked in the upper right hand corner. But if you want to see stuff like that and what I am doing right now, which is a bunch of CFD, then that link is in the description, where if you get a free account, you can join in the podcast conversation, which the next episode may or may not be a talk with Braden Carlson. If you don't know that name, then I'll link his channel in the description. But if you don't want to or can't support in that way, a like and a subscribe go a lot farther than you might think. And actually, according to the analytics on most of my videos, there are currently over 200 viewers who are not subscribed. If you're not aware, that is the majority of my viewer base that is not subscribed to the channel currently. So help push us over the 500 sub point and subscribe. It's free. It helps a lot more than you would think. Also, make sure you have checked out the website where we have all our upcoming flights, past sponsors, past flights, flight failure analyses, rest in pieces, Dart. You can also ask questions for the podcast on there, but until then, my name is Liam P. I will see you next time.